Welcome back. In this video, we're going to run a little science experiment. So let me demonstrate how it's going to work. I have a cup of dirt, which is now all over my computer. And that's dry dirt. I have a cup of wet dirt or soil, and that's not all over my computer. I have my microbit, and I have a couple of alligator clips connected to my microbit, and at the end of my alligator clips, I have connected some paper clips. These are going to be my probes, and what I want to do is I want to probe the soil to see how wet it is. So I'm going to put my two probes into the dry soil right now and demonstrate how this works. First of all, you can see I have a little bar chart or bar graph on my microbit that is trying to show about the level of moisture that's in the soil. Actually, a lot of the electricity that I'm sending out, I'm getting back about, it looks like 80% of it. What I did as well is I programmed so that when you press the A button, it gives you a number, 534 in this case. So that number tells me that's how much electricity I'm getting back out of how much I sent out. Now I sent out about twice that amount, 1023. I'm going to put these probes in the wet soil. So those probes are now in the soil. And you can see my bar chart here is completely filled up. And now if I press the A button, and let me hold it down, I can see I've got 1023 coming back to me. And that's actually the exact amount that I sent out. So I'm getting all the electricity back that I sent out. That means that that soil is wet and this other soil is dry. So let's go ahead and let's code this and see how we can go about doing it. What you're going to need for this experiment is you are going to need 2 alligator clips. You'll need 2 paper clips, 2 cups, 1 cup half filled with dry soil and another cup half filled with wet soil. You'll need your microbit, and you'll want a USB connector to connect it to your computer, and potentially you're going to also want a battery pack so that your microbit doesn't have to be connected to your computer to be able to use this. So make sure you have all the materials you need, and once you have that, let's get coding. So to start coding, we want to go to makecode.microbit.org. Now at makecode.microbit.org, we are going to create a new project, but first I want to show you where this project comes from. If you'll scroll down, you'll see there's some tutorials. In your first week, you should have done one of these tutorials here, these simple tutorials where you've got these games, as well as a radio game. Well, we're going to scroll down a little bit further, and there is a section for science, and what we're doing right here is the soil moisture experiment. So if you don't want to listen to me, you can go to the soil moisture experiment. It'll teach you how to do it. I'm going to show you how to do the more advanced of the two that they show you in that experiment. So let's get coding. If you scroll back up to the top and you click on new project, go ahead and let's call this moisture meter or something to that effect. I'm going to call this moisture meter. And I'm going to just make sure I say that this was done in winter of 2021. And go ahead and create that moisture meter. So like always, we start off planning this out. This time we're going to plan it a little bit differently, or we're going to use an event we haven't used before. We are going to use the forever loop, which is right here. What I want to do is I want to be forever sending out an electrical signal and then seeing how much of that signal I get back. So I'm going to right click on forever and add a comment. And I'm going to pull this comment off to the side and expand it a little so I can write this out. So what I want to do is forever send out an electrical signal. And let's say we will send that signal through pin 1. So you'll notice over here on your simulator, you've got several pins on your microbit, 0, 1, 2, 3 volts, and ground. So we're going to send some energy out through 1, and then we're going to see how much of it comes back to 0. And that'll tell us how much moisture is in the water, or rather how the ions are passing the electricity through the soil, right? And water helps facilitate that process. Water itself doesn't conduct electricity, but the minerals in the water push the ions forward, right? And so the more water there is in the soil, the more the electricity will flow through the soil freely. So we're going to say we're going to send that back through pin 1, and then what we're going to do is we are going to read how much electricity we get back. Electricity is returned through pin 0. And then we're also going to show a bar graph of the result. And if we press the A button, let's say the A button, then show the numerical value. So we have kind of two outputs of this. We'll have a bar chart output and a numerical output. And then it's always good to put just a wait at the end so that we'll say wait 1 second because you might be interfering if you are forever reading this. It's nice to put a little bit of a pause in there so it reads 1 second and then another second and then another second instead of constantly. Otherwise, sometimes I found that the readings aren't entirely reliable. So let me go ahead and number these so they're easy for us to read through. That's 3, a numerical value, and then we'll put 4. So that's our plan to be able to create this moisture meter. All right, so I'll just call this our moisture meter. So now that we've got our plan, let's go ahead and plan it out here, or program it out. So forever, the first thing I want to do is send out an electrical signal. The way that I'm going to do that is I'm going to use, over in some of the advanced code here, I'm going to look at the pins area. So click on advanced and scroll down to pins. Once you have pin, there's several different options. You have the ability to write. That means to send energy out through one of the pins. I can write digitally or I can write using analog. Now a digital reading is either on or off, right? So we get the signals being either zeros or ones, or either on or off digitally, right? What I want to do is I want to use, instead of a digital, which is just going to be completely off or completely on, I want to use an analog reading for the pin, or write to the pin in an analog way, which means I can send anywhere between some zero value and some top end value, right? Now, the microbits are usually powered by 3 volts of energy. And in make code right here, 3 volts of energy in whatever values they're using to write to these pins converts to 1023 in this case. So that's our top value that we can send out, is 1023 of these units allow us to send out 3 volts of electricity. So I'm going to pull out here analog write pin. Once I've pulled this out, I'm going to put that into the first thing that I want to do. And I'm going to write, I think I set to pin 1. So I'm going to actually send energy out from pin 1, and I'm going to send out all 3 volts. That's the most that I can send out. You can see over in the simulator that right now it's simulating that it is sending out a full value of 1023 on 1. And it's forever doing that right now. So this is why it's pretty constant over here as it's sending that out. So the next thing I need to do is I need to create a value that I can read from. Right? So anytime that you want to track one piece of information and you want to store that somewhere, where do you store it? Hopefully you said in a variable. So I'm going to go over to my variables and I'm going to create a new variable, and let's call this variable something like moisture level. That makes sense. That's a good name. Moisture level is the name of my variable, if I can spell it. Okay, so now I've got a place to store my moisture level. What I'm going to do is I'm now going to set moisture level to however much of that energy came back to pin 0. So I'm going to send energy out through pin 1 and read how much of that is coming back through pin 0. So in order to do that, I'm going to go back to my pins. So if you don't see the advanced categories, click on advanced, scroll down to pins, find pin, and in this time, instead of looking at analog write pin, we're going to read. And we're going to read from pin 0. So we're writing out to pin 1, and we are reading from pin 0. And then just so that I'm not constantly sending this energy out and trying to read from it at the same time I'm still sending more out, I am going to turn off the energy in pin 1. So I'm sending out bursts of energy rather than a constant stream. That'll make it easier for me to read how much of it's actually coming back into 0. So I'm going to go back to my pins, and I'm going to grab analog right pin, and this time I'm going to write nothing to pin 0. And you can see here the values all along the way. I can go from 0 to 1023. So in this case, I'm going to send out 0 to pin 1. So basically, I sent a little burst of energy to pin 1. I'm reading how much of the energy comes back through pin 0, and then I'm going to set pin 1 to 0. So this way, it's just sending it out in bursts of energy. And now I've done both number 1 on my plan and number 2. What I want to do now is this showing a bar graph, and it looks like I numbered these things wrong. So I'm going to show a bar graph, and in order to do that, I could go down to images, which is in my advanced as well. And there's lots of different options here in images. Oh, and actually it looks like it's not quite the image I wanted here. So what I'm going to do instead is I'm going to use the search bar up top to look for bar graph. I just type bar graph. Sure enough, I find there is a code block that says plot bar graph. So I'm going to pull out plot bar graph, and it's going to ask, well, what am I plotting the graph of? In this case, I want to plot whatever my moisture level is, right? So where did we store that information? That's right. We stored it in our variables. So go back to variables, find moisture level, and pull moisture level into your bar graph. Plot bar graph of moisture level. Great. Now, we want to set the top value of this bar graph, right? Because right now it's saying, well, I know what the moisture level is, but I don't know what that is in relation to what my top value should be, right? Since the top value possible is 1023, I'm going to set the bar graph to go up to 1023. So this way, if we're getting back all of our energy, our bar graph should be full. If we're getting back 80%, we should see about 4 bars. 60%, we should see 3, and so on. So now we've done number 1, number 2, and number 3. What we need to do is we also want to see if we can get the numerical value. So it's a little bit more precise as we read through this. So we're going to say if we press the A button, then show this numerical value. So if I go back over to input, I can look and see on A button pressed, which is what we've used so far. But instead of that, I actually want to use something different. Because I've written this as if we press the A button, and I'm in this forever loop, instead of that, I'm actually going to go into my logic and find an if statement. So I'm going to pull this if statement out, and now it's looking for what is the condition I'm looking at. Well, the condition in this case is whether or not the A button is pressed. So click back on input, and the fourth block down says button A is pressed. So this is kind of another way of checking if you've pressed a certain button, where you can check inside of other code that you've done instead of creating its own event for pressing the A button. So right now I'm saying, well, if the A button is pressed, then what do I want to do? Well, over here in my plan, I've said then show the numerical value. Okay, I know how to show values, and I know how to show numbers. If I go to basic, the very first block is show number. So I'm going to pull out show number. And what is the number I want to show? Hopefully you've said moisture level. So go back to your variables and grab that moisture level and drag moisture right into where you're showing the number. And hopefully you're seeing how useful it is to have created this as a variable, because now we're using it in multiple places. And anytime you're going to use a single piece of information in multiple places, it's a good idea to store it as a variable. So we've pretty much done everything that we have on our plan, except for this last one, which is wait 1 second. Again, the reason I like to put a wait in there is because we are constantly running this loop, since it's a forever loop. And I find that when I'm trying to do a moisture reading, I get a much more accurate reading where it's not interfering with itself all the time and just keep resetting all the time. So it's probably a good idea to go back to your basic blocks, scroll to the bottom, grab a pause, and put a pause in. In this case, I think I'll put a 1 second pause, which is 1,000 milliseconds. So this is pretty much our code right now. We can see we've got, reading through this forever, it's going to write, it's going to send a burst of energy out through pin 1. And then we're going to set a moisture level, which is some variable that we just created. And we're going to set moisture level to however much of the energy is coming back through pin 0, because we'll be reading the energy through pin 0. And then we're going to stop that burst of energy in pin 1. we're going to create a bar graph to whatever our moisture level is up to the possible top amount, which is 1023. And then if we're pressing the A button, we do want to show the number to scroll across the screen of whatever the value is of moisture level. And then our code will wait 1 second before it'll go through that whole process again. So if you think you're ready, let's go ahead and download this to our microbit. So I'm going to click on the download button. And I need to find my microbit on my computer. In this case, if I scroll over on the left-hand side, I can see I have the microbit is one of the items on my computer. If you don't get a screen like this, remember to check your downloads folder or wherever your default download is. This is all depending on how you've got your own browser set up, and a lot of people, their code will automatically save to the downloads folder. So download it from there and then drag it from your downloads onto your microbit. I'm going to click on save. It's going to transfer that data using and gives us a little bit of feedback using this blinky light thing, right? So now we've got that feedback with the blinky light going on. So let's test it out and see how well it works. I've got my moisture in front of me. I've got my towel so that I don't get dirt on my computer, but of course I knocked over my dry soil again right onto my computer. So I got a towel here so I don't get that on my computer. And I can see right now with my probes not connected both in the soil, I'm not getting really a lot of energy back. And the reason for that is because I haven't completed the loop, as it were. And actually, I should let go of this. It's probably getting a little bit of energy from me because humans are also great conductors of electricity. So a little bit of electricity is getting back through pin 0, but it's really not much. If I were to put this into my wet soil, you can see it's gone all the way up to the top, right? So I'm like, oh, that's a lot of energy is coming back. Now, I have connected my one of my probes to the 1 pin, and I've connected my other alligator clip to the 0, and both probes are in the soil so they can complete that electrical loop. If I look at this now and I press A, I have found, in this case, it says if I'm pressing A, so I need to hold that down. I get 1023. So I'm getting all my electricity back. This is wet soil, right? Well, let's test this against the dry soil now. So I'm going to take both of my probes that I've created with my paper clips, and I can see right now I'm not getting as much energy back. I'm getting quite a bit back, but not as much. This is pretty dry soil, so let's see what we're getting back. If I hold down the A button, I can see I'm getting 745 units back, right? And you can see there that bar graph is showing me it's not quite as much. So this is a great experiment you can run in a lot of classes. Students will often plant seeds and grow those in the back of their classroom. So you could enhance that activity by having students program a soil moisture meter. These things aren't the most precise things in the world, right? I mean, we're using paper clips as our probes. So I would have them take 10 readings and maybe take the average of those 10 readings of the difference between wet soil and dry soil, so the students will know at what point do they feel that they should water the soil. In fact, if you really wanted to extend this over the course of a longer unit, you could potentially even have them create a system that will automatically water the soil if the soil drops below a certain value. And to do that, you have some other items in your maker kit, such as straws, and just with the straw and maybe a motor, which I didn't include in here, but maybe a servo motor or something like that, which are usually around $1 to $2. You could actually have your students program an automatic soil moisturing system to be able to keep their plants watered. So hopefully you can see some of the potential things that you might be able to do to be able to use microbits to enhance your students' hands-on science activities. Go out there, imagine what you can do, and have fun with it.